So to respect the people who have joined, welcome to the East Central and South Africa Microsoft Excel Forum, brought to you by Crisp Excel Training and Consulting. To support the webinar, please subscribe to our YouTube channel. There are also other more master classes that you can see. Today, I'm excited to have Pieter. Pieter is an Excel process automation, a self-taught Excel solution creator, data analyst, and a corporate trainer. You can follow Pieter on social media. I'll share his LinkedIn link. And our topic for today is the unknown reduce function. So Pieter, I think you can start. Yeah, you can start, and then as we wait for other people to join.
Okay. First, a little introduction about myself, I guess. I'm 48 years old. I never got taught Excel at school or anything. I just started working and used Excel as a grid holding, text or numbers, and I didn't really know anything about it until I found out there was more to it than storing that text. It could also calculate and much more. So I started viewing what others did and how it worked, and it made me grow. And eventually, I started solving challenges, and it keeps make you grow your knowledge in Excel, and the energy you put in, you get back from Excel. So it helps you in day-to-day work. So today I'm gonna present something about the reduce function. It may be overwhelming to some people because it's not a function that has if you type it in, that you see right away what is the demand of the function. So I'm trying to explain the syntax at first, and then show some of the capabilities of reduce, because it's really a very diverse function. And hopefully there's some tricks in there that surprises the people that already know the reduce function. There's I guess I just start. So I have a simple sequence here of numbers 1 to 6. If you type reduce, it says initial value, array, and function. So initial value, it's good practice to have, if you work with numbers, a 0 or a 1, and with text, an empty or a string something. For now, I will do this, 0. Then the array, which is this range. So it's a spill range, so you can start referencing B2, and the rest of the spill is by the hashtag. And then you have a function. So in this case, you can at once sum it, and that will result in the sum of all. That looks very simple, but there's more to it. Reduce was initially not a function that could right away use the eta sum. This is a lambda representation of sum. It's actually this lambda AB, and A is that initial value, and B is the input value. And if we do sum A, B, that's the same as we had before. So it's still 21, and it sums A and B. But what it really does is and I can explain this with the same but doing in scan. If we change the reduce to scan, then it says first it is 1 because it sums the initial value of 0 with the first, which is 1. Next, it sums that previous value, 1, with the second, 2, and it becomes 3. And next, it sums that value with 3, it becomes 6. So it's cumulative, and reduce only shows the outcome. So scan shows all the steps, and reduce shows the outcome. But in this case, it's not really a good practice to use reduce, because we can use sum right away and we have it. But we can use the same and do something else with it. So reduce, and we do the same. I start with 0 and I take that range again. I type lambda A and B, so A for the first value, and A becomes the calculation result of the reduce the next time. So that is changing constantly. So A, B, and then we do our calculation, and in this time I do A and B, and then we get a concat of A and B. And if I do is odd B, then we get, if it's odd, A and B, and otherwise B and A. If is odd. So now it divides the odd and the even to the right and to the left. And this is how it works. I do the same using scan. So it starts with that 0 value, then it checks if the B value, which is 1 at first, is odd. Yes, it is. Then we stack the B value to the 0 that was there. Then the next one is even, so it gets stacked to the left instead of the right. And so on and so on, and the end result is the result of reduce. So again, scan and reduce in this case are very similar, but reduce only returns the end result. Also, if we do the same logic and use it here. Here you get one result, and I'm going to change a little just to show an extra. So we can also do this, A and B, and then B and A. This will error. And the reason is these are numbers, but as soon as you use the ampersand, it becomes text. And if I do minus A, which is the calculation result of the previous, so it's a text, minus text will result in an error. So if we want that minus to be there, we need to refer to it as text, and then we get the same, but with a dash in between. And the reason why I also show this is now we see a difference, or not really a difference, but we see the order of how the range, the input, is being calculated. So we have a 2D input. It starts here. This is the next. So that is something to keep in mind if you have an input which is not a 1D array, then this is the order it is calculating. Then we can also use a VStack inside reduce. I'll show that. So is reduce, and we will start with I don't know, I call it stack, and we use this range lambda A and B. I use this because I like short. You can have actual names for that and refer them in your formula. That's something personal, I guess. So I was going to use a range. So I am gonna sum VStack. I was going to do VStack A, which is the start, but also the following result of the accumulated calculation. Sum. And then I'm going to use this cell up to B, which means B is that input, which is this, which goes from the first, the second, etc. up to the end. So what you have as an input for a reduce can also be a range and can be referred to as a range inside the calculation. So if I do this, we get stack. That was the title I gave as an initial. Next, we get B7 to B. So B7 is here up to the first, and the sum is 15, which is correct. And then one less, 14, 12, etc. up to the end. And to make that better visual, we can also use this and change sum to arrayed texts. And then you see what it's summing there. So it is really a range you're referring to, and it's changing while looping through the values. Then you can use reduce for looping through arguments in functions that that if you use them, they only accept one argument at a time. An example is this: substitute. I want to substitute this word, this characters, for these characters. If I do this, it does that on the original for each character, but not all together as an end result. So to accomplish that, we can use reduce, and then the input, the initial value, is the initial word. We are gonna substitute. Next, we can do two things. I have here sequence and I have range. In case of sequence, we have 4 rows for each. So I'm going to use sequence for lambda A, B, and then substitute A, the initial value, the initial word, and I'm going to substitute it with index, the character, and B is the first of the sequence 4, and then the next, and then the next. And replace it with index is B. So then we get a way different, another result. And I can show you how that works using scan. So what it does, it changes ng from change into x, so checks, and then from this it changes ch to o, is this result. Next it changes e to er, that result, and finally ax to vh, and then you get this. So functions like text join, you can use is reduce, join sequence for E A index of that, and then B Text join. So I reference the index of these two columns. That's why I had to use 1 and 2. And then use text join on that, and then I get a BYROW text join. Sometimes reduce is not the right choice because using the VStack on heavy calculations that makes well, it is heavy on your computer, and sometimes it's better to choose a different option. But it's a function that can do well, almost anything. But be careful not to always dive into reduce. Sometimes it's better to look at a different option. Now I used a sequence. We can also use a range for doing the same, which is a bit harder to understand than using the index if you have two columns, but I'll show. So index word, and then we're gonna use, I'm gonna use the second column as an input, lambda a b, and then I'm gonna do the substitute. And now I have my b, which is the replacement column, but I don't have the character column. But I can refer to it using the b. So because we have a range, we can, for instance, use offset b minus 1. So a column to the left, and then replace with b. Oh, and I have to tell that I use it on a. So then it does the same. We don't use the index and the sequence, but we use offset. But some people hate to use offset because it makes it volatile, and every time you change something in a sheet, it will recalculate. And if you have a heavy calculation, that's not good. So we can also avoid this by, I'll show that first. We can refer to equal to. So here we have a range, and then I want to have the intersection of that range, but it'll create a value error. Why? Because if I put it here, is intersection. The intersection needs to be is at plus. So now intersection of a deranged range. So the range becomes an array, as you can see. And then the intersection automatically becomes the first. on a range, on an array. So we can use that inside here. So instead of offset B, we can use, I will start at the last value of here up to B, and then use that same. So at plus, and now what it does, it'll loop through these values up to here. So it starts from NG to TH, next CH to TH, E to TH, and AX to TH. And as you can see, now we avoided using the offset, and we get the same result. And then I have another one. So Fibonacci sequence. This is particularly a sequence that you can use reduce on. So the Fibonacci sequence is a sequence that starts with 0 and 1, and from there on, each value becomes the sum of the two preceding numbers. So 0, 1, sum of 0, 1 is 1, sum of 1, 1 is 2, sum of 1, 2 is 3, etc. So how we are going to do that with reduce is we do exactly what the text says. We start with 0 and 1, so reduce 0 and 1, and I use a semicolon, and the reason is if I use a comma, 0, 1, the array will go to the side, and if I use a semicolon, then it is from top to bottom. So in some system languages, there's different characters to do this, but I'm using the English version. 0, 1, and then we can use a sequence, or doesn't really matter. We can also have the size of a range as an input, lambda A B. So what we're going to do is we're going to stack the first, and then from there on we're going to take the previously calculated or initial value, and then the last two values. And then we have the 0, 1 as a start, and the size of the input range, it starts calculating that sequence. So we can also use sequence 99, and then we get that sequence, and here is the scientific notation of that, because it gets too large. 50 numbers is big enough for Excel. Okay. Next, I'm gonna start with well, I called this sheet Lookup. I'm trying to XLOOKUP and then look up the result using the same logic, and then loop through that. So I'm going to start with doing an error, and then I'm going to explain why. Reduce, and we're going to look up these values as a start value, and then in the size of the number of rows, there's that many options that they can have a Y value. We're going to search for, well, the XLOOKUP value. So lambda A B, or maybe XY, because I named them that way. So we're going to do XLOOKUP, and then we're going to look up X here, and the result is that. And as you can see, this errors as I announced. And the reason is, well, XLOOKUP, if it doesn't find anything, it starts looking from A to B, and it does that 4 times. So B to C, C to D, and D has no found, so it errors. So if D is not found, we want that X value. So the XLOOKUP, lookup value, lookup array, return array, and if not found, we want X. But this is not correct, because E does not relate to D. And the reason I'm going to show by manually doing the lookup. So is here I have a copy of the first, and then next I'm going to do the XLOOKUP on that. XLOOKUP, this here. Yeah, so I'm locking the cells, so if I move them around, they stay in the same position in the formula. XLOOKUP, so, and if I drag this, the reference is correct, but the results show the NA for D, which is correct because there is no D in column X. So now I'm going to show why it errors. So what I did in the reduce formula, I used the initial lookup value as a if not found. So I'll do that here too. And then we get an error. And why is that? Because it does not accept a range for that if not found. So we need to make an array of that. So the plus. But then we get F cycle to B. And if we move that on, we all get the D. So that's what happens here. And how to bypass that? Well, I think it's a design flaw in the XLOOKUP. So if not found, it results in NA. And NA error does accept a range. So we can wrap that around if NA So now, if we drag it, we get correct results because A will look up to B, B to C, C to D. and that for all these values, and E will stay F, which is the final. So here we can do the same. If not, then we use X. So X being the input value to search for, and if not found, it stays that input value. And then we get the correct end result. We can also accomplish this doing a recursive lookup. So I don't know if you saw Craig last week. I'm gonna do a simple recursive lambda. His was much more advanced. So I'm gonna use let, and I name lookup, and I use two inputs for that. And the first one will be the function, and the next one will be the input. So let C is X lookup, and then we're going to look up the input, which is the B, the second, and then we'll look up here and there, and then we're going to tell Excel if the lookup returns in an error not found. So if C errors, then we use the B, the input value. And otherwise, we need to reloop. So we need to use A on itself and do the lookup. And then we have loop up on itself and input A, for instance. Oops. Yeah. Oops, I think I did it wrong. Yeah, here. Oh, it corrected a lot. One moment. X lookup if isna B. There. Okay. Yeah. So if we look up A, it becomes B, B becomes C, C becomes D, and D will error, so we keep D. But we want that on the whole array. And then it says, but we can simply use map for this, and then do the same map lambda, and I call the mapping range M. So if we do that lookup on M, we get the same. So that can be used as well. And the logic is quite the same as reduce. It reuses its own calculation, and reduce has a more hard-coded stop. So the size you input is the size of the number of calculations, and this iterates until it reaches the point, in this case, the ISNA. Then a little more on reduce. We can use VStack and HStack as I've shown before, but we can also tell Excel if this, then that. So is reduce, and then a start value, and I take an empty one, and I get back to that later. And then the range, lambda A, B, and then I'm gonna tell if is odd row B. So my input range, if the row number of the current cell is odd, then VStack A. So the previous result or results and B, and otherwise HStack A, B. So as you can see, it stacks, but it also creates a lot of NA. The reason is if it stacks something below and next it stacks one value to the right, it doesn't know how to fill the rest. And also, I thought I'd get back to this. The start value, if we leave it empty, the first calculation is skipped and the first input is shown. So it starts right away with A, but it does not check this yet. And for the next calculation, it'll start its logic. So that can come in handy, and sometimes that will not be handy, but it's good practice to use a first initial value. But in this case, it comes in handy. Now, what do we want to do with the NA? We can tell Excel if, I'm going to do it on the HStack, if NA, then row E, for instance. So as you can see, there's still some NA. This is because after H, there's still I, and this is an odd, and the odd has a VStack, and we don't have an if now on that, so it stacks errors. And for the rest, it adds the row number to the current size of the array. So A is the start, B is stacked to that, then it's no errors yet. Then we stack C to that, and that this is a VStack, so still it has an error because it's this size and this one contains an NA. But we did not tell Excel what to do yet, so it stays an NA. And next, we stack the D, and then it recognized that previous NA and the NA of the current, and it fills in that row B. What we can also do is wrap this all, and then value if NA, then row B, yeah. So now it fills all NA with the row number of the B value, also for the V stack. So it's a bit of a swirl, and maybe it's better visual if I don't use the row but the value itself. So we get A, B, and then it stacks to C, and also the error is also a C, then a D, then the E, F, G, H, Y. Yeah. And we can do the same in 4 directions. So if we have like row B3 and use mod on that, so we get a remainder of the number 4. So we get numbers 0, 1, 2, and 3. So we want to make use of that, or maybe I keep it there for visual, is reduce, and then we have the, I'm going to skip the initial value just like in the previous, and then have the range, lambda A, B, and then I'm going to tell, first I'm going to use let, just to let you know that it can also be used inside reduce. So let, and I'm going to use H for H stack because I'm going to use that function 2 times, and the same for V stack. And you can use a name and assign a function to that. So I don't type the text V stack, but the function V stack, or H stack in this case. So we can use that. So I'm going to do, I'm going to make use of that 0, 1, 2, and 3, and I use switch in this case, and then mod row B, or, and then switch 0 to V stack. Oh no, I have V, which is V stack, and then A and B. If we have 1, we do H stack, A, B. If we have 2, we do V stack, but the other way around, B and A. And if we have 3, we're going to do H, B, A. So again, the NA, so we're going to wrap the whole, if not B. So then we get a swirl of A, B, C stacked to that, D, E, F, G, H, and finally Y, I. So we can use a function, a name for a function, and use it later. To keep your formula short, it can make it more visible, but you have to understand, if you see this only, this part and you don't know about this, then it's hard to understand. So if somebody else is going to use it, maybe it's better practice not to do that. But sometimes it's better practice. And here we could also have done the same. So if is odd row B, then V stack, others H stack. And I'm going to name that C. So I make a check. If the input value row is odd, then it becomes V stack, C becomes V stack. If it's not, then C becomes H stack. So what we can do then is replace the V stack and use C. And then we have only one if not, and one function, which can be either V stack or H stack, depending on row B being odd or not. And no matter what, the IFNA returns B. So we get the same result, but I like the logic better. It's basically the same, but yeah. And then I have one more to show capabilities of reduce. So we have 3 columns, X, Y, Z, and we want a report built in a way shown here. This is something reduce can do. If you use it on large data, it may become not the best choice, but it is capable of doing things like this. So I'm going to show it. So I'm going to start off with reduce, and the start value will be the YZ. So I select them. And I'm gonna, so the logic here is that for each value that is found in X, we create a mini report. So we want to know how many different values there are in X. So a logic choice would be unique. So, and maybe it's good practice to name X and then we can refer to it like that, and then lambda AB. And now we are gonna start building the report. So V stack A, so we're gonna stack the report on the initial, the YZ. And first we want a blank. I do something wrong first and then explain. So a blank, and then we want a filter on the values of A. So filter the values of Y and Z, where X, which we named here, equals the current unique X value of the input B. So what it returns now is also already something. So we have the header, we have an empty with an NA, and the same reason it happened here. We have a size 2 array, and we stack a single cell to it. So either we make it the correct size, or using IFNA. In this case, I do it like this. But we also wanted the header and also a total sum of that value. So maybe it's good practice to store this. So we're gonna name this let. I'm gonna use F for filter and then paste that filter here. So I can replace this with F, and now nothing has changed yet. But now we can do first add that header, that subheader. So the X and B, which is the current unique value. And then we get another NA because of the size. So we could also use IFNA. Yeah. So there we have, up until here, we have it correct, and then we need to add a total. And that's the reason why I stored the filter here, because we want a total of the Z column. And we have that Z column in this filter here. So we can add that. So we need HTAG total there, and Z, yeah, can do it in the text. Z, yeah, total Z is and stack the total of it, and that's the total of the right side of the filter that we already have in place. So take the filter and have the last column, -1, is the first one from the right, and sum that. And then we have our report. And I think that shows many of the capabilities of reduce, and hopefully it helped some of you understand the function, and maybe it showed some tricks to the people who already understood the function. And I hope it was not boring.
Not at all. Very, very interesting. Thank you very much, Peter. Thank you for. I think I need to rewatch the whole webinar like 3 or 4 times. There's so much to learn from. Before I ask you my question, if there's anyone with a question, please raise your hand, and then I'll make you a presenter, and then you can ask your questions. So thank you for mentioning the negative side effects of reduced function, about taking too much consumption power, and also for showing us alternatives. Yeah, so I think that was great.
Yeah, it's a function that can do a lot, and that tends to it tends to be the first choice if you don't know how to tackle something. Reduce will be your first thought, but it may not always be the best.
Yeah. Thank you for that. Anyone with a question? Okay, can see a couple of questions. So let me make you a presenter. Or you can allow mic. So if you had raised your hand, you can allow I've allowed you for the mic. You can unmute yourself, Michael and Oscar.
Okay, thank you, Peter.
You're welcome.
This is really a good addition to reduce. We've been checking around for a number of examples from whatever we get. Like I've recently been watching some and Cell, Trump Excel. It's been also having good examples, but today I've gotten very good use, especially the last one, where you have real combinations to make a report out of all the good uses of dynamic array, new functions. Really, there are very few examples around, and this one is, at least I can walk away with the last one, where we have the combinations up to where you sum the take. Actually, I've been looking for a good example of where to use take, because it's a way of using the last column. Many times you are able to sum. Really, it's a good use. Thank you so much for this.
Thank you. I'm glad it was helpful. Yeah.
Oh, thank you, Michael. Oscar, if you can unmute yourself. There's someone who is asking for examples from the workbook. I'm sure you're going to share with me the workbook so that I can share with others.
Can you repeat that, Chris Paul?
I'm saying there's somebody who is asking you a workbook, so I'm thinking you share that with me later.
Yeah,
the
no problem.
That you have used.
Yeah, no problem. Yeah.
Okay. Oscar says, excellent presentation, Peter. It was desirable, a double reduced example like submatrix omic charge. I don't understand. If you can check the charts, Peter, I don't know.
Let me
Something
see.
about the double reduced example.
I am gonna stop sharing and then find the chat. Here, chat.
Anyone else with a question, you can raise your hand and then I'll unmute you.
It was desirable, a double reduce example, like the submatrix omic challenge. I do a lot of challenges and I don't really know which one it was.
Oh, okay. Okay.
But I really like those challenges, so keep them coming.
We'll do our best. We'll do our best. If there's anyone else with okay, thank you for the presentation. Hopefully you come back again and teach us more on the map and the scan and the array to text and the other not well documented functions by Microsoft. I think Microsoft is not doing well in the documentation of these new functions. So thanks
No,
to
exactly.
people like you. Yeah.
But I also think reduce is hard to document.
Yeah, true. Yeah. So hopefully you come up with other examples for the other functions. So yeah. So Helmut says, now I see reduce in a different light. Until now, I have largely avoided using it. So at least you have converted somebody to using reduce. But Helmut, as Peter said at the beginning, it is power hungry. It is what? How can I? It is very heavy function. So please don't use it all the time. Look for an alternative before you go for it.
Yeah, especially if you use the V stack and the H stack, that is heavy on the processor.
Yes, it is. It is. Yeah. Yeah. So thank you for coming, Peter. Hopefully we'll see you back again.
Yeah, it was a pleasure. So yeah.
Yeah. Bye.
Okay. Bye.